day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Matsidiso Kongwani. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Okay, grade 12, since we are writing tomorrow our June paper 1, our focus today will be on revision of paper 1 on selected topics. And then now in this lesson we will revise the equations and inequalities, and then this is composed of 50 plus minus 3 marks on your paper 1 out of the 150 total of your paper. So grade 12, can you see that the equations and inequalities, they play a major role on your paper? Remember, equations are also applicable to other topics on your technical mathematics. So this is a big topic in technical mathematics. And then now we'll also look at the differential calculus together with your integration. Differential calculus together with your integration. Remember, when you talk equations and inequality, we are also including your complex numbers. That means all your complex numbers, they fall under equations, algebra on equations and inequalities. And then in addition to this one, remember paper 1, you also have your finance, growth and decay, of which is worth 15 plus minus 3 on your paper 1. And then you also have your functions and graphs, of which is 35 marks plus minus 3 on your paper 1. That means now the two topics that are taking most of your marks, those are equations, inequalities, complex numbers with binary, differential calculus and integration, of which they both worth 50 plus minus 3 on your paper 1. Hence our focus will be on these two for today. And then the pre-knowledge that we need, grade 12, since we are going to be busy with the equations, mainly focusing on the quadratic equation. And then you remember that the standard equation for your quadratic equation is ax squared plus bx plus c. And then this must always be equals to a 0. That quadratic equation, when you are solving an equation, it must be equals to a 0. But the a value can never be 0 now, grade 12, because if you put 0 here, this whole term now will be 0, and this equation will never be quadratic again, because to be quadratic you must be x to the power 2. Okay, so that is why we are given a restriction that a cannot be equals to a 0. And then out of this now we will be applying the quadratic formula. And then before you apply the quadratic formula, your equation must be in the standard form. What do we mean by standard form? It must be written in the form where it starts with an x squared. As you see, it's ax squared starting there, followed by bx, that means a value with x, and then now plus c. C is a constant number without x. Therefore, this is the standard formula. Standard form we are talking to. And then after arranging in the standard form, ensure that your right hand side is equals to a 0 or this equation is equated to 0. It is only then that you can use your quadratic formula. And quadratic formula states that x is equal to minus b plus minus the square root of b squared minus 4ac over 2a. And then this quadratic formula, grade 12, you will find it at the back of your question paper on your information sheet or the formula sheet. That is the first formula on your formula sheet. And then now be careful now. The value of b is the one that is coefficient of x. The value on this b is exactly the same as that one because it's b and b there. And then now for the value of a, which is the same as that one, it is the coefficient of x squared. Whatever value that is written before x squared, that is your a value. Coefficient of x, a value next to x, it's your b value. And the value without an x is your c value. That is a constant value there. And then we will also look at the inequalities. Remember now, inequality is not an equation. Remember, equation is working with equal sign, but inequalities are using the greater than symbol, less than, greater or equal to, or the less and equal to. And then now, if we are working with these two here, of which is the less than and the greater than, if you look at this, there is no equal or below your inequality sign. That means now for that one, use the notation with an open dot, as we can see that we have indicated. Use open dot on number line for both critical values if your inequality does not have equal sign. And then now the round brackets interval notation, critical values not part of the solution. That means now the notation that you can also use for this one is either it's an open dot, or your notation can use the notation bracket of open brackets, grade 12. And then this simply means now, this notation means the critical values are not part of your solution. And then now if you have an inequality sign that is stating greater and equal to, or the less and equal to, now you use a shaded dot or a closed dot like that one that we have there. Your dot must be shaded and the notation must be of a square bracket, meaning that use shaded dot on number line for both critical values, and then the square bracket interval notation indicates that critical values are part of your solution. I hope the notations are clear to us now. And then now here I have something for you for warm-up for 3 minutes. It's a baseline assessment, and then you are given the formula on the left hand side, and then yours is to indicate to me on that by completing this table, when do we use the x equal to minus b? What is the name of that particular formula? Okay, and then where do we use that one? The x minus b, the I effective, the a of 1 plus minus in, and the a equal to p into 1 plus I to the power n, and the f at x is not for the first time grade 12. You see these formulas and then label them then on the right hand side using the table given to you. That is a 3 minutes activity, and your 3 minutes starts now. Okay, grade 12s, remember our WhatsApp number 079 454 9535. You are more than welcome to send your clarity seeking questions to that particular number, or any alternative solution that you like to share with the rest of the group. Our WhatsApp number is 079 454 9535. Okay, let's see now. How far did you go with this one? Do you know what is the first formula? That is our quadratic formula, okay? That is the quadratic formula that we use for factorizing. You can use this quadratic formula to find the solution for any quadratic equations, grade 12. But remember, your equation, we are using ax squared plus bx plus c. It must always be equal to 0 before you can use this particular formula. And it must be arranged in order. Start with the x squared followed by x and then the constant number there. You can't use this formula before you arrange according to the correct order there. Sometimes you might have an equation that is not having a c value, that is x squared plus bx and then equal to 0. So that means in this case your c is 0 there. Or you can have a condition that you are having ax squared plus c equal to 0. If b is not there, that means your b is equal to 0 in this case, okay? And then for this case, if c is not there, that means your c is equal to 0. That means grade 12, for all the conditions 1, 2, 3, you can use your quadratic formula then to answer your questions. And then now the second formula is the x turning point formula. And then now we use, when we are looking for the x turning points of a parabola function. And then this is also depending on that quadratic formula. Can you see that it plays an important role in your equations and inequalities? So the b value that you are talking to is the same b that we have on your quadratic formula. And the a value that you'll be substituting there is the a from your quadratic formula. So it is used to calculate the x turning point of your parabola function. And to find y, you know that you just substitute x into the original, then you'll have your y value. And then the next formula is used in financial mathematics now. When you are calculating the effective rate, that is why we have I effect, that EFF stands for effective rate. So this is the effective rate formula. IN indicating the nominal given to you, and then M and M there is the same thing. Compounded monthly, it will be 12, quarterly it will be 4, and so on. And then this is a -1, not equal to, it's a -1, okay? And then now the next two formulas, still they are financial ones. Remember these three, they are financial formulas. One for effective rate. This one is for the simple interest, whether it's a growth or a decay. And then we know that for simple interest, we use the abbreviation SI with capital letters. And then now when the IN is a linear function, straight line, it has a relationship with the straight line graph, grade 12. And then this is a simple interest. And then we use this in hire purchasing. When you buy the furniture at the house, they are using this calculation to calculate the interest in. And then we have the compound interest. We are using the symbol CI for the compound interest. It can be interest growth or a decay. A growth is when you are investing, your money is growing. A decay is when the value goes down. For example, when you buy a cell phone now, after 2 years, the value of that cell phone will depreciate. That is a decay now, because the value will be going down. You buy a house, the value of the house decreases after some, or the house increases always, sorry. It's a growth house. It's a good investment because values of the houses are always going up. But you buy a car now, and then after 2 years, it won't be as new as now. So there will be a scrap amount that will be calculated on that old car now. It will decay the value, depreciate the value as you drive the car for some few years. So those are the real life application. And then now, how do we know that this one need to be compounded? N must be on the exponent there. Then you must know that is the difference between a simple and a compound. The n here is an exponent, the n there is the multiplication to I, of which is straight line. So now when we talk to simple interest, this is having a relationship with the straight line graph or the linear graph. And then now the compound one, as you can see, n is on the exponent. That means it's having a relation with the exponential function. So now it can be given also the calculation of this in terms of diagrams. You must know the relationship and how to relate to the interest there. And then lastly, I have in the first principle, this one is the formula that is used in differential calculus when you are determining the gradient or the derivative of a function using the first principle. The minute you see this first principle, that means they are saying to you, apply this formula. So all of these formulas, grade 12, you'll find at the back of your question paper on the information sheet or your formula sheet. Right, now let's start with the first topic, revision of equations and inequalities. Now remember, we said that if you use a quadratic formula, your formula must be written in the form ax squared plus bx plus c equals to 0. Yes, happy, now the right hand side is equal to 0 there. Yes, but if you look at the left hand side, you don't see the x squared, the bx. That means they have already factorized for you, grade 12s. Because now if you multiply this back, it will be 2x squared minus 5x equals to a 0. That means we do not have a c 0 there. But there's no need for this, grade 12, because now if it's bracket equal to a 0, they have already factorized for you. Do not waste time. That is why we are having 2 marks there. They are telling you go straight to the answer. So the first x here will be equal to 0, or the 2x minus 5 will be equals to a 0. So this is your first solution. And then now we need to deal with this one, 2x transpose minus 5 to the right, it will be positive 5. And then from here, what must we do, grade 12? Divide both sides by 2. Then your second x will be 5 over 2. So his 2 mark is 1 for x equal to 0 and 1 for x equal to 5 over 2. Hence, we have allocated 2 marks for that problem. Can you see that? No need for multiplying out, because you might do mistakes and so forth. As long as the brackets are equals to 0, do not multiply. Go straight to the answer, right? Let's look at the second one again. This is equal to 0, happy, brackets on the left, happy, they have already factorized for you. Yours is to say what? X plus 7 equal to 0, or 3 minus x equal to 0. Straight to the solution. And then now x is equal to transpose 7 to this side. This is minus 7, or x to this side so that it can be positive. Now it will be 3 equals to x. Then your answer is x equal to 3 and x equal to minus 7. 2 marks for each. Then that is why this is worth 2 marks. And then now look at 1.3 now. With 1.3, we have 2 brackets. Yes, we can assume that this is already factorized for us. But in this case, we do not agree with you. Why? Because the right-hand side is not equals to 0. These are factors only if the right-hand side is equals to a 0. So grade 12, in the case there where it is not equals to a 0, that means you need to multiply out your bracket and transpose to the left what is on the right hand side, so that everything goes to the left hand side. So now grade 12, this simply means we have a lot of work on this one, hence the mark is 4 marks, and then hence you are having the message that is saying correct to 2 decimal places. Why are you having this message, grade 12? This is automatically telling you that this problem doesn't have what? The factors. You need to use the quadratic formula in order to find your factors. These factors are not the rational factors, okay? That means they are irrational, so you need to use your decimal places. that means you need the quadratic formula. Hence they say round to 2 decimal. Let's start now. We must start by removing the bracket. That is 1.3. We have x minus 3 into x plus 1, and then we have equal to minus 2. Use distributive law. X times x is x squared. X times 1 is x. Minus 3 times x minus 3x minus 3 times 1 minus 3. Transpose minus 2 to the right. It's a plus 2 equals to a 0. Happy now we have equal to a 0 on the right hand side. Now you check like terms. X squared is the only one. And then now we have plus x minus 3x, that will be minus 2x. And then we have a minus 3 plus 2, that is minus 1 equals to a 0. And then we are looking for factors of this. 1 when you subtract to get 2. Is it possible? No, factors of 1 are only 1 times 1. There is no way that you can have factors of 1 when you subtract them, they will give you minus 2. It's a misconception, grade 12. Most learners will be writing minus 1 and minus 2, but minus 1 and minus 1, that will never work, because now they will never give you the negative 1. So hence we have this message, there are no factors for this grade 12. For an example, let's say now this learner thought that the factors will be x minus 1 and x minus 1. Let's see now, when you multiply, this will be x squared, and then minus x minus 2x. But look at the last term, it will be negative 1 times negative 1, which is plus 1. Therefore these factors can never be a factor to the trinomial, because now they give us a plus 1. So in order to find the correct one, you are relying on the quadratic formula because of this message here. So that means you will need the value of a, the value of b. Remember the original is ax squared plus bx plus c. That means the value here is the one that is the value of a. For the value of b, we are having that value. For the value of c now, we have the minus 1. So happy grade 12, can you see that if you put this equation next to your equation, it can guide you now that your a is equals to 1, your b will be minus 2, and your c will be a negative 1. And then now into your quadratic formula, you check this at the back of your formula sheet. X is equal to minus b plus minus the square root of b squared minus 4ac over 2a. The division line must start from the negative there, grade 12, and the square root sign must include everything up to c here. It must not be on b squared only. That is the mistakes that you do when you note this equation. Please do it correctly. So, and then now we have a negative from the formula, negative from the formula. And then our b is negative 2. That means it comes with another negative, okay? Plus minus b is the same, negative 2 squared minus 4. And then our a is 1 and the c value minus 1. We are now substituting in the values, and then we have 2a is 1. And then now our x simple side form, it will be, if you put this into your calculator, grade 12, before you press the SD or the change button on a sharp calculator, you leave it in a simple set form. So if you put this into your calculator and check the answer, it will say 1 plus minus the square root of 2. And then now you press SD button or change button. This will give you the first x value. Consider 2 decimal places, right? So the first x value will be 2,41, or x is equals to a negative 0,41. So those are the expected solutions, grade 12. Let's look at the mark allocation now. The first mark is for multiplying this out to get the correct trinomial there. That is your first mark. Second mark will be for substituting into the correct formula. The third mark will be for the first x value, the fourth mark for the second x value. Hence, this problem is worth 4 marks, grade 12. Continuing now to the next, we are still solving for x. We are given x squared plus 5 is equals to 0 here. And then now we are solving for x again. And then now we need to answer this one and check. So now the first thing that you'll be doing, I know you'll be checking factors of 5, right? If you check factors of 5, is only 1 times 5. And then the trinomial is saying take factors of 5. When you add them, they must give you 4. Is it possible, grade 12, to have factors of 5 when you add them 1 and 5 to get a 4? No. That means you need to subtract, and this is not allowing us to subtract. The statement on the trinomial is saying when you add, you must get a positive. So that means this will never work for us. So that means we go for our assistant, our helper, the quadratic formula, minus b plus minus the square root of b squared minus 4ac all over 2a. Remember now from the original equation, ax squared plus bx plus c equal to 0. This will assist you. The coefficient is 1 there, goes with an a. Therefore, the a value is equals to 1. And then now we have the b there, goes with the b. And then the b value will be equals to 4. And then the last one is the c value that goes with the c there. That means our c value will be equals to 5. Right. And then now we can now substitute into the formula, that is x, a negative from the formula there. And the value of b, fortunate enough, it is positive. It will remain positive. Plus minus the square root of b is equals to 4. Squared minus 4. Remember, this division line must cover everything. And then a is 1, the c is 5. And then all over 2 into 1. And then now there comes a problem, grade 12. When you punch in through your calculator says error. Okay? The minute the calculator says an error, that means with mathematics, whatever is inside the square root here is negative. With maths, they will say non-real roots. But with technical math, this is imaginary. So the minute it is imaginary, it is bringing in your complex numbers. That means after substituting, grade 12, I'm repeating, you substitute into the quadratic formula. You put everything into your calculator. Your calculator now says error. The minute it says error, go and check inside the square root only. So when you check inside the square root, we have 4 squared minus 4 into 1 into 5. Now we check this value now. When you check this, you find that this value is giving us a negative 4. That is the reason why your calculator is saying error, because we can't find the square root of a negative number. So we are bringing in your complex numbers, grade 12s. For maths is non-real roots. And then for us, we'll be having minus 4 plus minus the square root of minus 4 now, all over 2. And then remember now with complex, this will be minus 4 plus minus the square root of 4 times negative 1 all over 2. And then this is the same as minus 4. The square root of 4 can come out of that and becomes a 2. Then you'll be left with square root of minus 1 all over 2. Then we simplify this now. 2 goes into both of them. 2 into minus 4, it will be minus 2 plus minus, then the 2 here will go once into 2, you are left with the square root of minus 1. What is the square root of minus 1, grade 12? That is your complex number, minus 2 plus minus I. Can you see now you are having 2 conjugates here? So now with this type of the quadratic, you'll be having conjugates. We have the first solution as minus 2 plus I, or the second one will be x equal to minus 2 minus I if we are separating this part here. Can you see now this is conjugate to each other? It is always acting like that because of the plus minus that is on your equation, grade 12. you can't get any two different solutions. It must be conjugate to each other. Right, we are done with question 1.4. And the mark allocation here, it will be 1 for substituting into the correct formula. And then the second mark is for writing this in terms of -1 there after taking the square root of 4. And then the third mark will go for the first positive value, the last mark for the negative I value there. Then this is 4 marks. I hope you are happy with that one. This is more familiar to you, grade 12. It is in most of your papers because this is only applicable to technical maths learners. And then 1.5, this is what we call the literal equations. We are still solving for x here. That means it's where they say make x one letter to be subject of the formula. If they say solve for x, that means they want you to make x the subject of the formula. So our targeted variable is x here. We need to simplify and ensure we are left with x equal to something. Okay, let's start now. We are having our formula A is equal to half 25 f with x squared and the close bracket. We are targeting this one, so you need to get rid of everything here. Okay, let's start with the half now. If we multiply by 2 here, both sides, then 2 will cancel 2. You'll be left with 2a is equal to what is inside the bracket, 25f x squared. Okay, we are targeting to remove 25f, so we'll divide by 25f both sides. So 25f will cancel 25f, then you'll be left with x squared on the right hand side equal to 2a over 25f. We do not want x squared, we need only x. Then we will get rid of a square, and then this will create a plus minus the square root on the left hand side of your 2a over 25f. That is the solution for x in terms of a and f. Solve for x in terms of a and f. So now the question that will follow on your question paper grade 12, you will be given the value of a and the value of f, and then they will ask you to calculate the value of x. Now to find the value of x, they will give you a and f. You just substitute in here and then you get the x value. Okay, now the allocation of marks, the first one will be multiplying both sides by 2, the second one for dividing both sides by 25f, the last one for bringing in the square root sign with the plus minus. Then that is the 3 allocation of marks. Remember, for every side, when it loses an exponent, the other one will gain a plus minus. Is 2 solutions, grade 12 for that. Okay. And then now still on equations and inequalities, we are now looking at the inequalities. We said for an inequality, we must see the notation greater than equal to, or the greater than or less than equal to. Then it is no more an equation, but it is now an inequality. So now let's look at the first inequality. Do you still remember the method, grade 12? We must start by factorizing. So you can use your quadratic formula, it's fine with me, okay? Or you can check factors of 10. We are having 1 times 10, we have 2 times 5, and the 5 times 2, and the 10 times 1. That means for 10, these are the only factors that we have. And then out of these factors now, you listen to your trinomial. It is saying factors of 10. When you subtract, you must get a 3. So which one can give you a 3? Can 10 and 1 give us 3? When you subtract, no, they are giving us 9. Can 5 and 2 give you 3 when you subtract? Yes, that means we are relying on 5 and 2. So we can now bring in our factors, greater than equal to 0, x and x from x squared, and then factors will be 2 and 5, the correct ones. And then in order to be plus 3, that means the bigger number must be positive. This one will be negative. Why? Because it is a product of negative 10. So now we criticize the values for now. Why do we criticize? It's because we are writing them in with an equal sign. So the first bracket will be x equal to 2, or the second bracket will be x equal to minus 5. That is why we are saying critical values, because we are using equal signs there. Remember, our solution must be in an inequality sign, not equal sign. Okay, now we bring your number line, start with the smaller number followed by the bigger one. Always remember your number lines, values on your left hand side are the smaller ones, on the right hand side bigger. And then now this way you are becoming small, that way you are becoming bigger. Okay, and then now we look at the inequality sign. It is having an equal sign, then it will be a shaded dot because the values are part of the solution. Included. Now grade 12, remember the tip I gave you last time. If it is open to your equation, this is open, that means is this bringing O also there, which is for O, and then it will give an O below there. The minute you have an O in between, that means it is separating the solution. It is telling you your shading will go this way and that way, because there's a split between your solution in between. So now this gives us x. The inequality sign here will be your inequality. The arrow will be the inequality sign. Minus 5, or x is the same, greater than 2. Because this is having equal sign, will also include the values, also included there with the shaded dot. So that is how you predict your solutions there. And then now this is worth 4 marks. The first mark will be for factors, second mark for critical values, the third mark for the first x value, with the fourth mark for the last x value with correct notation, of which this is worth 4 marks, grade 12. And then now the second one is minus x squared plus 16. Do you still remember now, if you are having a negative on your x squared, this is going to have an impact on your inequality sign, because you cannot factorize with this negative here. You need to multiply throughout with that negative. Let's multiply now. Multiply by negative is becoming positive x squared. Multiply 16 by negative, becoming minus 16. And then the inequality sign will be affected now, becomes a less than 0, no more greater than, because of this negative. It has a power on changing the inequality sign. Right, grade 12, if you look at this, this is the type of factorization of the difference of two squares. Okay, oh, it's fine, you can use your quadratic formula if you want, but with this quadratic, remember now, original quadratic is ax squared plus bx plus c equal to 0. So if you look at this equation, is equation x squared minus 16. That means coefficient of x squared is a. It's fine with that one. Do we have bx? No, that means the b is 0 here. We don't have bx, that means the b is 0, something like 0x. And then now the c value will be the constant 116. Okay, let's say this learner now decided to factorize with the quadratic formula. Remember, this will be x equal to minus b plus minus the square root of b squared minus 4ac over 2a. And then now the b value is 0. Plus minus the b value is 0, squared minus 4a is 1, and the c is minus 16, all over 2 into a. The a value is 1, so we substitute 1 there. And then now we will get the same x values, grade 12. Your calculator will give x equal to 4 for positive 1, and the x equal to minus 4. For the negative x value. So now it's either you use your the quadratic formula, or you just write, if you know your maths, that if you are having this are difference of two squares. Difference is the answer that you get when you subtract, hence we say difference, okay, of two squares. This is a square number because it's x squared. Difference 16 is the same as 4 squared. It's a difference of two squares. Can you see that you have a square with a minus? That means it's a difference of two squares. Now grade 12, this can be separated into two brackets. We know the rule of factorizing difference of two squares is that now you will share equally x and the 4. The only difference is that one bracket will be negative, the other one will be positive. And then now when you criticize values, now you'll be having x equal to 4 or the x equal to minus 4. The same applies grade 12. If you use your quadratic formula, you need to criticize your values. And then now to move to the number line method, and then this smaller value minus 4 bigger value is equal to 4. This inequality sign doesn't have an equal sign, therefore the values are not part of the solution. They are excluded. Round circles, round brackets, okay? Open dots, not shaded, because they are not included. Now, if it is less, remember now with the greater than, it's open, and then now it's separate solution. And then with less than, you are losing weight, you are becoming less, and therefore now you come in, shading will be here. Your solution will be inside, okay, because you are now less than. Greater than, you go this way, less than, you come in. And then now your x will be in between the minus 4 and the 4, because the shading is in between. Okay, you don't include the values now. Can you see? No equal sign because it was not given there. And then grade 12, be careful, do not use this initial inequality. You use the 1 after multiplying with the negative. Hence, we have shaded less than. Okay, be careful around that one. And then this is 5 marks. 1 mark is for the correct notation with the correct inequality. Number 2 is for factors. Number 3 for critical values. The first x value with correct inequality, and the second value with correct inequality. This is worth 5 marks. And then now we move on to simultaneous equations, grade 12. Remember, when we talk simultaneous, you are also going to apply this in complex numbers where we have two unknowns. With simultaneous, because we are solving two unknowns, solve for x and y simultaneously at the same time. Solve for x and y at the same time. So if we have such case where you have two unknowns, we get this in complex numbers. We find this when you are doing functions at the point of intersection, the graphs are equal. You are solving for that point, x and y values. So you need two equations. The other one will be a linear, the other one will be the quadratic one. And then now this is equation 1 and equation 2. Out of these two equations, grade 12, choose the linear equation, okay? And make one variable to be the subject of the formula. So we are going to take the 5x minus y equal to 2 to create equation 3. So now, if we take 5x, this y will remain minus y. We want y. We are targeting y because the coefficient is 1. But now it's having minus y. Oh, the easiest way, grade 12, is to take y to this side so that it becomes positive y. And then you'll take 2 to that other side. So the left-hand side will be 5x minus 2 equal to positive y. So this is your equation 3. After identifying 3, now you'll substitute equation 3 into equation 2. You can't substitute on the same because it's the same equation, this one. It's the one that created this one. There's no way you'll substitute in that. We take the one that we didn't use, of which is x squared plus 4x minus y equal to 8. So wherever we see y, we are going to substitute 5x minus 2. Happy, x squared plus 4x minus, there must be a bracket because there's a negative out. Bring in y, 5x minus 2 equal to 8. So now grade 12, the next step, now you need to remove the bracket. That will be x squared plus 4x, negative times positive, negative 5x, negative 1 times negative 2, that is positive 2. Transpose 8 to the left, minus 8 equals to a 0. And then now we check like terms now, that is x squared, 4x minus 5x, minus x, plus 2 minus 8 minus 6 equals to 0. Yes, you can go your quadratic formula to find the values there. That will be comparison to ax squared original, bx plus c equal to 0. That is a, that is the value of b, and that is the value of c there. Okay, we can now substitute our values. A is 1 and b is minus 1, the c is minus 6. Into the quadratic formula, x is equal to minus b plus minus the square root of b squared minus 4ac all over 2a. And then what is b? It's a negative from the formula. The negative from b value, negative 1, plus minus the square root of b is negative 1 b value squared minus 4. The a value is 1, the c value minus 6. We are substituting into the correct formula. 2 into 1. Please double check your formula, grade 12. That is exactly the same as the formula on the formula. Do not assume that you are correct. Verify by looking on the formula, because we encounter learners who copy this formula incorrect. Okay, and then after substitution, do not try to partially solve. Put everything into your calculator straight to the answer, and then this will be given the first x value being equals to 3, or x equal to minus 2. Remember, we are solving for both x and y. Up to this far, we have only solved for x. We also need to solve for y. To solve for y, take the easiest formula that we have created there, which is equation 3. It is saying automatically y is equal to 5x minus 2. So for x, first x, we are substituting 3 minus 2, that is 15, minus 2 of which is 13. Or for the second x value is equal to 5 into x minus 2 minus 2. 5 times negative 2 is negative 10 minus 2, that is negative 12. So those are the y values for those particular x values. Now let's allocate marks to this problem, grade 12. Can you see it is worth 6 marks? So simultaneous equation is 5 to 7 marks allocation. Please go and practice this. It has a lot of marks. First mark for just indicating to us the correct equation 3. Then you'll get a mark for that, because we needed something that says y equals to. It cannot be y always, grade 12. Sometimes it can be x that is on your favor. So check which one can you use. The easy one, okay? So now it's 1 for that equation. Second mark is for substituting that equation into your equation of a quadratic. The third mark is for the correct trinomial there. And the fourth mark for substitution, correct substitution into the quadratic formula. The fifth mark, it will be for the first x value and the second x value. The last one is for calculating the correct y values there. Then this is your 7 marks, grade 12. So do not stop. When you have identified your equation 3, you have substituted, because you're struggling, most of you, is to find this equation correct. Do not stop there, grade 12. Whatever equation you have there, it must be a quadratic one, and then you can substitute into quadratic formula and continue with whatever you are having there to the answer. And then now the marker will look into your solution, whether the mathematics was correctly applied into that particular problem. And then now grade 12, let's check now from you. This is your activity. Can you do this on your own, we are having solve for X activity. There I am giving you 3 minutes, exactly 3 minutes, grade 12, to solve these two problems and give us the solutions. Your 3 minutes starts now. Okay, grade 12, let's see how far did you go. We are still on quadratic equations. For the first one, it's very easy, right? Because it is equal to 0. You have brackets, they have already factorized for you. So now yours is to say what? X is equal to 0, or the 2x is equals to minus 7. If you transpose 7 there, divide by 2 both sides, therefore x is equal to minus 7 over 2. Then you have your 2 marks, grade 12. This is worth 2 marks. And then now with the second one, you have a message there, correct to 2 decimal places. That means this needs a quadratic formula. It is already calling for the quadratic formula, right? And then now look at the equation now. This must be in the format ax squared plus bx plus c equals to a 0. Only 3 times grade 12 that we need. But if you look at this, we have more than that, and there is something on the right hand side. Then you need to simplify before you substitute. Let's simplify now. We have 3x squared plus x. 6 to this side is minus 6. 5x minus 5x equals to 0, and then that is 3x squared, and then is plus x minus 5. We are adding like terms, that will be minus 4x, and then the last one is minus 6 equals to 0. And then since the message, you don't even want to check the factors, we go straight to the formula. Remember, this is your ax squared plus bx plus c equal to 0. That is your a, that is your b, that is your c value. Then let's substitute into the quadratic x minus b plus minus the square root of b squared minus 4ac over 2a, correctly copied from the formula sheet. I've already checked my formula sheet. This is correct. And then now before I substitute, then I have a negative there, and the b is minus 4, comes with another negative. Please take note of that one. And the b is negative 4. Please also take note of the negative. Minus 4a is equals to 3, and the c is equal to minus 6. Also, this negative is critical. Most of you forget to put that negative for c. You take everything with its sign, grade 12. And then we have 2 into a is equals to 3 there. And then from here now, grade 12, we look at the simple set form for this particular solution. Then you'll be having 2 plus minus the square root of 22 all over. Your calculator will be showing this after your substitution. And then from here now you press the SD or the change button on Sharp Calculator. Casio, you use the SD button. Then this will give you now the answer in decimal. Remember 2 decimal places, and this will be 2,23, or the x will be equals to negative 0,90, grade 12. That is your solution, and this is worth 4 marks. The first mark will be for the correct standard form, second mark for substitution into correct formula for the first x value, for the next x value there, then that means this is worth 4 marks. And then now grade 12, now an activity again on inequalities. I am giving you 3 minutes. You are solving an inequality and the simultaneous equation. After that, we will reflect back. Your 3 minutes starts now. Okay, grade 12. Now let's look at 1.1.3. This is an inequality type. And then remember, you look for factors of 10. When you subtract them, you get a 3. And then if you factorize this grade 12, you'll end up with a x plus 5 and the x minus 2, which is less than or equal to 0 into the number line, because this will give you critical values, x equal to minus 5 or x equals to 2. So the smaller one, minus 5, followed by the bigger 2. It is a shaded dot because it has an equal sign. And then this is less than, that means you are shading in between. Then your x will be less than or equal to minus 5, or x will be greater than or equal to minus 5, or x less than or equals to 2 there. So that is your solution. And this is worth 1 mark for factors, 1 for critical values, and 2 marks for your solutions with correct notation. And then with the simultaneous equation there, grade 12s, we are having equation 1 and the equation 2 there. We need to create equation 3. So now here we are going to target y because it's coefficient 1 a positive. It's up to grade 12 if you want to target that one, but we are avoiding negative. You know, if it is negative, you need to transpose that to the right. Remember that one. So here I will use y because it's easier for me. So I leave y and transpose minus x to the side. It will be positive x with the 2 that is already on that side. That is our equation 3. And then we are going to substitute equation 3 into equation, the one we didn't use, that is equation 2. And then equation 2 states that x squared plus y squared is equals to 20. So wherever we have y, we are going to substitute x plus 2. So it's x squared plus, for y, we put in x plus 2. And this is squared equals to a 20. And then now the next method is brackets. Remove bracket, x squared. So that means this one means you are multiplying through 2 bracket of x plus 2. Okay, that will be x times x, which is x squared. 2 times x, 2x. 2 times x, 2x. 2 times 2 is a 4. So that is x squared plus 4x plus 4. Okay, or the short method, you can say x squared is x squared. X times 2, 2x times 2 exponent, that is 4x. Square the last term, 2 squared, that is a 4. Can you see you get the same answer as that one? And then after that, transpose 20 to the left, it's minus 20. So we add like terms, that is x squared plus x squared, that is 2x squared. 4x is the only one x. And then now 4 minus 20 is minus 16 equals to a 0. So grade 12, you can go to your quadratic formula with this one, or you can divide by 2, but throughout it's up to you. So let's go ax squared plus bx original plus c equal to 0. That is the a value, that is the b value, that is your c value. Into our quadratic formula, x is equal to minus b plus minus the square root of b squared minus 4ac over 2a. I hope you are now familiar with this formula. We've been using this a lot today. And then it's a negative. What is the value of b? That is 4. Plus minus, it is still 4. Squared minus 4. A is 2. And the c minus 16. And then all over 2 into a, 2. And then now into your calculator, grade 12, to the answer. It will give you your first x value. The first x value for this one will be a minus 4. And the second one will be x equals to 2. And then now you're happy, now you have your x value. But remember, you are solving for x and y. You still have to find y. We are going to take the equation 3 to make our life easier. 3 states that y is equal to x plus 2. We are going to substitute our x with minus 4. The first one, minus 4 plus 2. Minus 4 plus 2 is minus 2. Second, y value On the same equation, x plus 2, we are now substituting x with the 2. That will be 2 plus 2, of which is a 4. Therefore, these are the y values for that particular function. So the first mark will be for the third equation, second mark correct substitution, the third mark the correct trinomial equation, fourth mark for correct substitution into correct formula. Mark number 5 is for the x value, the second x value 6, and the last one for both y values. Then this can worth 5 to 7 marks, grade 12s. And then now let's talk to binary numbers. The easiest simple way of answering binary, grade 12, is to use your calculator. Okay, the sharp calculator is the good calculator for binary because it's having binaries. Unfortunately, we do not have binary on the Casio calculator there. The Casio FX82 doesn't have binary numbers. You need to buy those expensive ones, the 999 ones. But with the sharp calculator, of which most of you are having, it can assist you to find the binary now. They say express 24 as a binary. If it is 24, that means this is a decimal number. Decimal, the calculator is automatically on the decimal mode. The minute you switch on, calculator is on decimal mode. That means if you are working with decimal to binary, that means now you'll just put in 24, you press 2, followed by 4, and then now the second function, and then you say now you change this to binary, you press that division line. Can you see on top is written binary there? You start with the decimal value 24, your calculator is already on decimal. Put in your decimal number 24, and then you press the shift second function button, and then you press the division line, which is your binary mode. Then this will take you straight to the answer that 24 is equal to the binary value of which is 11000. Don't forget to put your base 2 there. Then you'll get your 1 mark, grade 12. No hassle, no need for those long methods. This is only worth 1 mark. That means you are allowed to use your calculator there. And then 1.4, evaluate 144, divide by 110, because binary numbers are represented by 1, 1, and 0 only. And then you'll see with this base that this is in binary mode. So it's 144 decimal, divide by 110 binary, and leave your answer in decimal. That means now if they say leave your answer in decimal, it's better to change everything into decimal. So we are going to change this 110 to decimal now. Okay, the first thing that we'll be doing now before we can divide, you're going to take this 110 now and change it to decimal. Because you are changing from binary, your calculator must be in a binary mode, grade 12. And then how do you put your calculator on the binary? You start by saying second function, I'm changing my calculator to binary. So it's second function, a division line of binary. Then the calculator will show bin here, and then with 0 with bin there. That means now it is now in a binary mode. Then you can put in your 110 into your calculator there. Okay, and then now you say second function more, and then now you want to take it to decimal now. You are reversing now. You start from binary to decimal. You must change your calculator first, grade 12, to be in binary mode. That is second function binary on the division line. Okay, you put in your binary 110, and then you say second function equal sign to take it to decimal. Then this will give you a decimal value of which is equals to 6. This is now decimal. Therefore, we can now evaluate 114. It is actual 144 is divided by 6. So this is decimal answer equals to 24. Then you get your full marks. The first mark is for changing this to decimal and getting your answer in decimal form. So that is your 2 marks, grade 12. Your sharp calculator will help you. If it's on binary, start with the binary mode. If it's on decimal, your calculator must be on decimal mode. Right, and then now we move on to logs. Simplify the following without using a calculator, So for 1.1, we are having the log of a base a, and this is to the power half. Remember, we have rules of logs that we are applying under logs grade 12. There's a rule that says that if you are having this exponent, you can move it to be the coefficient of your log, so we'll end up with half log a base a. That is the first application. Another rule says that if a log is the same, like log 10 base 10 is 1, log 100 base 100 is 1, log b base b is 1. So in this case, we have log a base a. That means this will give us 1. So the answer for this will just be a half. Okay, and then now the first mark is for writing this as half log a base a, for substituting 1, and then for writing that as a half. And then for 1.2, we are looking at the set application now. We have the square root of 5x inside the square root into bracket square root of 45. Now you must write it in a simple set form. Grade 12, you can check with your calculator what is the simple set form. No decimals. We are working with sets without using a calculator. That calculator, we are using it just to check the simple set of square root 45, and this will give us 3 square root 5 x, and then now this is plus 2 times simple set of square root 80, that is 4 square root 5, and then x, close bracket. And then now we have square root 5 x into 3 square root 5 x. Getting these two, it will be 8 square root 5 x. And then now still inside the bracket, square root 5 x into 3 square root 5 x plus 8 square root 5 x. It's like 3 apples plus 8 apples. You'll be having how many? 11 apples in your bag. Okay, so the same applies here. We are adding 3 square root 5 x plus 8 square root 5 x. So we are adding the same thing. That will give us 8 square root 5 x's. So now continue grade 12. So we are multiplying in now because of this bracket here. It will be 1 times 8, of which is 8, and the square root 5x times square root 5x, it will be square root 5x squared. So this is 8, the 2 will cancel the root sign, we are only multiplying 5x. And then 8 times 5 is 45x. Then that is the answer, the simple set form for that particular answer. And then it's 3 times 8 plus 3 is 11 here. Okay, this is a mistake. It's 8 plus 3, which is 11. And then now we are having 11 here. Okay, let's do it again. Only this part, grade 12. It will be the square root of 5x into the bracket. 3 plus 8 is 11. Square root of 5x. Okay, my mistake. I took what is inside this, the root sign there. And then now we can now multiply. 1 times 11 is 11. And the square root of 5x times square root of 5x is 2. The exponent 2, and then now 11 into 5 will cancel the root sign, you are left with 5x. 11 times 5 is 55x. And then it's 1 mark for writing this in simple set form for all of them. And then secondly, now for the addition, and then the thirdly for multiplication, and then lastly for the correct answer for that simplification. And then now with the exponents, now we need to write this in the simple form. This will be 2 to the power 2 into 3x minus 2. With the prime base, we have 2 to the power 3n plus 2 plus 2 to the power 2n minus 3 multiplied by 2 to the power 3. And then now we are having there 2 to the power multiply 6x, 6n, we are working with n, 6n minus 4 over 3 to the power, 2 to the power 3n plus 2 plus 2 to the power 2n minus 6. We are busy distributing out of the bracket there, and then now multiplied by 2 to the power 3. This can join the top part because it's multiplication, it's over 1, remember, and then this can be multiplied by 2 to the power 3 there. Continuing with the same problem, grade 12, remember the rule that says the same base. When you divide, you subtract. When you multiply, you add the same base. Do you still remember that rule, grade 12? And then this is supposed to be multiplication, not addition. Okay, and then now we have same base 2. On top we have 6n minus 4 for this one. And then since we are multiplying, we'll add the next exponent, that is 3. And then on the denominator, because of this division line, when we move these exponents up, they will change its sign. That means 3n will be minus 3n, 2 will be minus 2, 2n will be minus 2n, minus 6 will be plus 6 there. So we end up with 2. Now we check like terms base 2, that is 6n minus 3n minus 2n, which is n. Okay, we have 6n minus 4 minus 3n minus 2 plus 6 then. Okay, and then from here now, let's check again, grade 12. It looks like there's a mistake somewhere. Yes, this is 2 to the power 3. That is 2, 3n, and then 3 to the power 9 there. Happy now. Let's check again. Is 6n, yes, minus 4, yes, plus 3, minus 3n, minus 2, minus 3n, and then the plus 9 there. Okay, and then this is 2 to the power 6n, minus 3 is minus 6, then it will give us 0. And then we have a minus 4 plus 3, that is minus 1. Minus 1 minus 2, that is minus 3. Minus 3 plus 9, that is 2 to the power 6. And then 2 to the power 6 is equal to 64, grade 12. So that is the answer for that particular problem, of which is worth 3 marks. And then now we look at the logs equations now. And then now with the log equation, when you have the log of 2x minus 5, 2x minus 5 divide by log 2, and then now is equals to 1. So this simply means now, grade 12, you need to solve this problem here. This is supposed to be minus, not division. It's minus there. So now if we are subtracting the logs, 2 logs, then you can divide the log. Then it will be the log of 2x minus 5 divided by 2, which is equals to 1. Remember the log, when you are adding, you need to multiply the brackets. And then if you are subtracting, you need to divide the bracket of the logs. So now here we are subtracting. This will be 2x minus 5 over 2, of which is equals to 1. Remember, if you don't have a base, this is base 10. So this will be basically 2x minus 5 over 2 when we apply the rule. And then this 10 will come in here and be a base, and then this will become exponent again. And then now we need to solve for x. We are going to cross multiply 2 to 10 there. This will be 20. And then now 2x transpose minus 5 to the right. It will be 20 plus 5, of which is 25. Divide both sides by 2. Therefore, x will be equals to just 25 over 2, grade 12s. Application of logs rules. Now exponential rules, logs rules, and sets rules, those plays an important role. And then you have 3x plus 2 minus 3. We are solving for x again. You start by separating the exponents here. Minus 3 to the power x still equal to 8 over 3. And then can you see the common factor on the left hand side? You take out 3 to the power x being common. And then if you take out there, you are left with 3 to the power 2, which is 9. Minus, if you take out 3 to the power x, do not write 0, grade 12. There's a 1 that is there. because it's 3x to the power x divided by 3 to the power x only once. This remains 8 over 3, and then now it's 3 to the power x. 9 minus 1 is 8, and then we have 8 over 3 on the right hand side. Divide by 8 both sides. 8 will cancel 8, you are left with 3 to the power x. So 8 over 3 multiplied by 1 over 8. When you change division to multiplication, remember 8 will cancel 8, you are left with 3 to the power x equals to 1 over 3. And then 3 to the power x, we are targeting base 3 because we have base 3 on the left. Then we write this in exponential form. It will be 3 to the power minus 1. Therefore, x is equals to minus 1. For the second one, we are still applying logs. It will be log of x. It's log equations, base 2. Then we take this log to the left hand side. It will be plus log x minus 4, base 2. 3 to this side, it will be positive 3. You still remember I said if it's a plus, then you will be multiplying your bracket with a single log. Then it will be log of base 2, x plus 3, multiplied by x minus 4, following the rules, and then equals to 3. And then now this 2 bracket will give us x squared minus 4x plus 3 is minus x plus 3 minus 4 minus 4, 8, 12. And then these 2 now will go this side and then become a base, and then that 3 goes to exponents. And then that will be x squared minus x minus 12 equal to 2 to the power 3 is equals to what? 8 grade 12. That is x squared minus x. We take 8 to the side is minus 8. Minus 12 minus 8 minus 20 equals to 0. Factors of 20, when you subtract to get 1, that will be x, 5 and 4. Okay, 5 times 4 is 20. Middle term bigger number, then this one will be positive. So the first x value will be equal to 5, or x is equal to a minus 4. Then this one will not be the solution because the log of a negative number is undefined. And then now on sets and exponent, now we are looking at the first one, grade 12. We have already done something like that one. Check the previous solution, and then let's focus on 4.2 now. We are looking at the simple set form of square root of 48. In the simple set form, you can use your calculator to check that one. That will be 4 square root 3 plus square root 12 simple set form 2 square root 3, and then 27 will be 3 square root 3. So you can see now you have created square root 3 throughout. And then it's a 4 plus 2 square root 3. This will give us 6 square root 3 over 3 square root 3. Then 3 goes how many times into 6? 2 times. Then the square root 3 will cancel square root 2. That is the final answer. And then with the log simplification, now look at this. You have different bases there. Okay. So now we can write 81 with the base 3. Is it possible? Yes, this 8 will be 3 to the power 4. So if you take 4 to the front, it will be 4 log 3 base 3, applying your rules now. And then sine 30 is equals to half. So this one will be minus log half base 2. And then minus log, the square root of 5 is the same as 5 to the power half, base 5. Do you see the idea around that, grade 12? We have 4 log 3 base 3 here. And then this half, we'll write it as 2 to the power negative 1. And the negative will go in front. It will be minus 1 log 2 base 2. And this half will go in front, minus half log 5 base 5. So can you see now you have log 3 base 3, of which will be 1, then it will be 4 into 1. Negative by negative is a positive, and then we have log 2 base 2, of which is 1. And then minus half log 5 base 5, it's 1. So this will be 4 times 1, 4, plus 1 minus a half, of which is 5 minus half. 5 minus half is 4.5, or a 4,5. So that is the answer for that one, great Charles. And then now we are expressing again binary. We've done the activity on that. Remember, your calculator must be in binary mode. You start with second functions, take it to binary, put in the binary number, second function to decimal, then it will give you the decimal that 1110 base 2 is equals to 14, great Charles. And then now with the next one, express 35 as a binary number. Your calculator must be on the original normal mode to be on decimal, right? And then you put in your 35 there. Put 35 on your calculator, shift to binary, then it will give you that 35 is actually equal to 100011 base 2 binary. The base is not there, remember to add a base. Okay, and then 5.3 now, evaluate 110, of which is this one, multiply by 35, of which is that one, leave your answer in binary. Because they want it in binary, we will take the binary 110 base 2, multiply the 35 in binary, which is 100011 base 2. And then into our calculator, your calculator must be in binary mode there. How do you take that? Is second function, the binary button. It must show binary before you put this 1110. And then now you can write exactly what is in there on your calculator. This will give you the solution that is 1111, and how many zeros? Or 01010 base 2. So that is your 2 marks. It will be for multiplication and binary to binary there. And then now with complex numbers, we'll be using the Z formula. A plus bi. A is the real part, the b is the imaginary part, and then we have the r of modulus and the theta angle, of which is the argument there. And then I've already talked to the complex and its conjugate. Or when we are doing quadratic formula, we only concentrate on the imaginary part with an I. Is the one that is changing its sign, only on I. A is not affected. And then we have the polar form. First notation is axis theta. Can you see it needs your argument and the modulus there? Okay. And then now this is the second notation, and the third one. It depends on the x, z, now which one is looking for. And then we have the simultaneous equations. That means complex numbers with two unknowns. This is the application that we use. You equalize the real parts together and then the imaginary parts together there to get your answers. Okay. And then now let's see the first activity on complex numbers. Express Z2. Z2 is this one in the form A plus B. Okay, Z2 states that is equal to half of Z1. Let's substitute Z1, half of Z1. Z1 is minus 2i plus 2. I have indicated my application, my multiplication with a bracket. The half of minus 2 is minus 1, then it will be minus I. The half of 2 is 1. But it must be in this format. Start with the real part followed by an imaginary part. That is how you write Z2 now, the real Z2. And then now write the conjugate for Z1. Z1. Be careful, grade 12. We are looking at the conjugate. Indicate the dash on top that you are talking to conjugate. This is not in the correct notation. It must be Z1. Start with the real part followed by the imaginary part. And therefore now if we look at the conjugate, it will be 2 plus now 2i. Please ensure the notation is correct before you conjugate, right? And then now the next one, it says simplify Z1 over Z2. Z1 divided by Z2. What is Z1? Is 2 minus 2i in the correct notation. Divide by Z2. What is Z2? We have already simplified. It's 1 minus I. And then now To simplify this, we must multiply by its conjugate, which is I plus 1 plus I, conjugate of the denominator, 1 plus I. And then now the simple form, we are multiplying these two now. It will be 2 times 1, which is 2. 2 times I is plus 2I, and minus 2 times 1 is minus 2I, and minus 2 times I is minus 2I squared, all over the I minus 1 minus I, 1 plus I. Those two are the conjugate. Therefore, they will give us 1 squared, which is 1 minus the I squared. So we end up with 2 plus 2I minus 2I will cancel. And then it's a minus 2I squared is a negative 1 over 1 minus I squared is a negative 1. So the final answer here will be the negative 2 minus 2, that is 2 plus 2 over 1 plus 1, of which is 4 over 2 equals to 2. So this is the simplifier of Z1 over Z2, okay? Or if they want us just to simplify like that, grade 12 without solving, so alternatively this will be Z1, let's see, over Z2, Z1 over Z2, and this is 2 minus 2I over 1 minus I. Let's see now. And then if you take out 2 as a common factor, you're left with 1 minus I over 1 minus I. And then the answer will just be a 2 for this one. That means, it simply means now our I is 0 there, okay? That is the simplest. But now if you are solving the Z1 over Z2, this is the method. That is the difference between the two. If they want the simple form of this, that is the simple form. If they want you to solve this, that means you are solving this division up to the answer of 2. And the activity on that one, grade 12, you look at that at your own time. And then now we continue. Complex numbers now represent the complex number Z1 equal to minus 2I plus 2. And then we are still continuing the same, and then they say represent the conjugate ZY on an Argand diagram. ZY, this one, on an Argand diagram. Argand diagram, remember, this must be written in a correct notation, that is 2 minus 2I. Okay, that means the A value is positive, that is the real part, is positive 2. And the imaginary part is a negative 2. So A is equal to 2, the B is equal to minus 2. So A is positive 2, and the imaginary is minus 2. So this will coordinate at this point. The diagram will be from 0, 0 to that point. That is the argument diagram for that particular equation. And then express Z1 in the form R sees theta. Now we have a calculator method that you can apply also to find this value. So on your sharp calculator, grade 12, now you need your A value, right, of which is equal to 2, and your B value being a negative 2. So you put in the 2 on the calculator, and then on your screen there you have a button that is written bracket X coordinating with Y. Can you see that button? Press that button, it indicates a comma on your screen, and then put in the minus 2 value now, negative 2 on your calculator, then it will give you the B value. So now on your calculator now you must have 2 with that comma with the minus 2 like that. And then now you go shift second function button on your sharp calculator, and then you press 8. On top of the 8 button there, it is written R theta. So this will give you an argument and the modulus values, okay? And then now you say second function, you press second function, grade 12, and then you press 8. Then it is given the R value is equal to 2,83, and then it is giving you theta value being the negative 45. It is giving you negative 45 because it's calculating in this direction. So yours is to add 360 to a negative 35, then this will give you 315 degrees, of which is the correct modulus for us. Okay, if your value is negative, just add a 360. Therefore, grade 12, your Z, of which is R cis theta, R is how much? 2,83, and then cis theta is 315 degrees. Then you'll get your full marks for that notation, grade 12. Always use your calculator, it's easier to do so. And then with the next activity here, we are having the simultaneous equation with complex numbers. Remember, we are solving for m and n. What you are looking for must be on the same side, okay? So it's 2m minus ni. So we are going to transpose this to the right hand side and also multiply the bracket out. Let's multiply the bracket. It's minus 3 times 4. That is minus 4, 8, 12i squared. Negative 3i times 5, that is negative 15i. And then 6 to this side, it's a positive 6i. And then we leave 2m minus ni because we are looking for m and n, equals to minus 12 into i squared, negative 1. Minus 15i plus 6, that is negative 9i. Then now 2m minus ni, a positive 12 minus the 9i. Look at the arrangement, grade 12. The i's notation of a plus bi, rectangular notation, okay? And then now the one without I is 2m will be the value equal to the value without I. Okay, therefore m is equal to 6 divided by 2 both sides. Or the minus n will be equal to the minus 9. We are taking coefficient of I equalizing to that. Therefore n is equal to positive 9. Then that is how you calculate the complex simultaneous. Then now we use differential calculus, first principle. Remember now the formula is f at x plus h and f at x over h. So here we are given f at x on both conditions. That means we must look for f at x plus h first. Then it will be f at x plus h. Simply means where we have x, we are substituting x plus h. Where we have x, we substitute x plus h. So we end up with 9x plus 9h there. So into the formula, f derivative of x, substitute f at x plus h, 9x plus 9h, minus f at x, which is minus 9x. We don't put a bracket because it's only one term. If it's more than one, please bring in a bracket over h. 9x minus 9x, we are left with the limit of h approaching 0 of 9h over h. The h into h goes once, limit of h approaching 0 of 9. Therefore, your answer is just the 9. Can you see this answer is exactly what is your coefficient? That is always the case, grade 12. Your answer will be the coefficient of x. For an example, if we predict this one, the answer will be minus 1. Okay, so now let's look at f at x plus h equal to 5 minus x plus h. Substituting x with the x plus h. So our answer will be 5 minus x minus h. Bring in negative there. So this is our f at x plus h. Into the formula, f derivative of x is equal to the limit of h approaching 0. What is f at x plus h? 5 minus x minus h. Minus f at x is 2 terms, then we put an important bracket. It's 5 minus x all over h. The limit of h approaching 0, that is 5 minus x minus h. We are multiplying negative in minus 5 and the positive x there all over h. 5 minus 5 minus x plus h. What is remaining? It must be in terms of h. Only the h is remaining there, minus h over h. H goes once, is the limit of h approaching 0 of -1. Your answer is -1. Do you see grade 12? Exactly the same as that one. And then now the rules, differentiation of rules. Remember, the notation is very important. If it is f at x, when you derive, it becomes f derivative of x. If it is d at x, your answer will just be that without dx. If it is in terms of 1, when you derive, it will say dy dx, right? And then let's derive the first one now. Okay, this is a constant number. Remember, this is 22/7. It's a value, okay? Now let's find the rules of differential. Here we are using rules, no more first principle. So this we are deriving f derivative of x, and then this will be 5 times 3, which is 15x. Subtract 1 from the exponent to the power 4. That is an answer for number 1. Number 2, we are having the square root is distracting us. We have x on the denominator there. We can't derive into that notation. So we need to change this, okay? Write this in exponential form. It will be x4/5. Write this in exponential, it will be 2/5, and then we take x squared up. It will be x to the power -2. And then now we have 8t to the power 4x, but we are deriving in terms of x, not t, And then now continue. Let's derive now. It's 4 times 1, 4/5. X to the power 4/5 minus 1 is -1/5. Check with your calculator, grade 12. Minus 2 times -2/5 is +4/5. X to the power, and the -1 is -3. Plus, you take coefficient of x. If it is to the power 1, then it's 80 to the power 4. You cannot derive a t because we are deriving in terms of x. And look at the notation, dx is no more there, okay, when you derive. So grade 12, that is your answer for number 2. And then for number 3, remember we are deriving y in terms of t now. So that means y must be subject of the formula there. So now let's do that. Start by simplifying. We are going to divide both sides. It's y3 t2 64 t to the power 11. Divide by t2 both sides. T squared, t squared, t squared, y cubed. And then t squared into t to the power 11, it will be 11 minus 2, which is 9. Then it's 64 t to the power 9. So now this side loses an exponent 3. This will gain a cube root or an exponent 1/3, or we can say we raise both to 1/3. Then this will be y this side, and then this side is the cube root of 64, which is 8, and then t 3 into 9 3 times. You will be left with 8t to the power 3. And then derive dy dx. This will be 3 times 8, which is how much? 8, 16, 24. This will give us a 24t to the power 2, grade 12. Therefore, that is the derivative of that particular problem. And then the last activity on the differential calculus, we are using first principle of this one. It will be f at x plus h first, which is x plus h. Remember, we are substituting there with the -5 into the formula. Derivative of x is the limit of h approaching 0 of f at x plus h minus 5 minus f at x, important bracket there, and then all over h. That is the limit of h approaching 0. And then now we are having x plus h minus 5 minus x plus 5 over h, x minus x, 5 minus 5. Always after this part, you must be left only with the h, everything with an h. And then this is the limit of h approaching 0, h into h once, then the answer. Look at the answer, no more limit on your answer, grade 12. On your final answer, there is no limit on that answer. Okay, moving on, we are applying the rules now to determine this one. The minute it says determine without saying anything with first principle, you must know that you apply rules. Okay, so 2.1, we have dx into that one. Yes, we can go straight to the rules. No simplification for that one. Is 9 times minus 3, 9, 18. That is 9, 18, 27. It will be minus 27, x to the power 8 and the minus 7. That is your answer, grade 12, 2 marks. Look at the notation, no more dx, right? And the 2.2, now we have f at x equal to that. We can't derive with the root sign and the denominator x there. Simplify first, it will be 3 over 2. We check x up, it will be minus 1. Write this in exponential form, it will be minus 2 over 5. What comes out of that? It becomes over there, okay? And then now let's derive using the rules. That is negative 1 times 3 over 2 minus 3 over 2. X to the power minus 1 times minus 1 is minus 2, okay? Negative 2 over 5 times 1, negative 2 over 5. X to the power minus 2 over 5 minus 1 is minus 7 over 5. Then that is your derivative for number 2. And then now, done on the previous activity, grade 12s. Please refer to that one. Remember, we started by dividing by t squared both sides, and then we ended with y cubed is equal to 64 t to the power 9, and then we involved the cube root or exponent 1/3 to both sides, and then we ended with y equal to 8t to the power of 3, and then now dy dx for that one is 8, 16, 24 t to the power 2 for that particular problem. And then now integration. With integration, it's very easy, grade 12, because now to integrate, you just check relationship between your problem and the rules on your formula sheet at the back. But we can't integrate with the bracket there. So get rid of bracket, that is 3x squared, and then 6x minus 4, that is 2x minus 8 for the last term, and then we are integrating in terms of x there. And then you check now according to the rules, all of them are x to the power 2, x to the power. That means they are all related to the first rule. It says that now you take out a constant number and derive this part and integrate this part by adding plus 1. So now we will leave 3 because it's a constant number, and then add 1 to the exponent. This will be also, this exponent is 3. That is the one that is coming below there. And then 2x is 1 plus 1, give us 2. That will be over 2. Minus 8x to the power 0. We add 1. That will be over 1. And then it's plus c because we have now integrated. Okay, 3 will cancel 3. Will be left with x to the power 3. 2 will cancel 2, x to the power 2. And then now is minus 8x plus c. That is number 1 solution. For number 2, can you see that? This is the same as integration of 3 over x, because now they're taking x to the denominator, that is why it's negative 1. So that means it is relating to this one. The answer will be, you leave constant value 3. And then this 1 over x will be a ln x plus c. Can you see, grade 12? As easy as that. And then the last one, number 3, we are having the integration of 4 and the integration of 2 to the power x there. So we are having 2 integrations. A constant is x to the power 0 is method number 1. So number, you leave constant value to the power 0, you add 1 over 1. And second application to the power x, can you see that? You leave a constant value. If you have, we don't have constant here, we have a value which is 2, okay? So that means it will be 2 to the power x as it is on top, and then below now it will be the ln of 2, because our a is 2 here and then n, we don't have the coefficient is 1, that means we don't write this one, and then plus c. So that is the, so to integrate, you simply apply this rule in relation to the problem that you are having there, grade 12s. And then now with the integration activity here, we are integrating minus 4. Remember, if we integrate a negative 4, that means in terms of t now, they are saying to you this must be minus 4 t to the power 0. And then now this will be plus 1 over 1. And then now we end up with minus 4t for that integration. Okay, and then the next one, we cannot integrate bracket. We must simplify this bracket. It will be x to the power 8 minus 9 x to the power negative 1, because we are adding the exponent. And then this is in terms of x. So let's integrate now. X to the power 8 is the first rule. That means it's x 8 plus 1 over 9. 8 plus 1 is 9. Minus 9, we leave the constant value is 9 over x. It will be the ln of x. And then plus c. So that is simplified part, it's 1 over 9 x to the power 9 minus 9 ln x plus c for that particular problem. And then grade 12, this is your homework taking home. That is applying everything that we have done with you today. All the best on your homework. And the summary of today is that we are looking at differential calculus, first principle rules and integration under algebra, number system, complex numbers and everything, equations and inequalities. And then the preview of the next lesson, grade 12, it will be on Friday, tomorrow, 2:30 to 4 o'clock, where we'll be doing June revision of exam paper 2. I wish you all the best, grade 12s, with your tomorrow's paper 1, and then Friday you'll be having your paper 2 sitting. Sorry, grade 12, tomorrow we are having paper 1, and then after your paper 1 you'll be having revision paper 2 online. Monday you'll be writing your paper 2. Thank you. This lesson is brought to you by Gauteng Department of Education in collaboration with Cyber Discovery Center. Thank you.